Web applications and associated threats. Today, the demand for web applications is on the rise. At the same time, most security breaches online occur through these applications. In this module, we will discuss about the web applications and associated threats.
By the end of this module, we'll be able to define web application, describe web application threats and vulnerabilities, discuss web app hacking methodologies, explain different web application hacking tools, discuss countermeasures for web application security, and illustrate the concept of web application penetration testing. What is a web application? Web application is a computer program that makes use of web technology and web browsers for performing tasks on the internet. A web application isn't really different from a native web application, just the platform is different. That is iOS or Android versus browser. Web applications use a combination of server-side and client-side scripts. The server-side scripts are used for handling storage and retrieval of information, whereas client-side scripts are used for presenting information to the users. This allows users to interact with the service provider or company through online forms, shopping carts, and content management systems. Web applications allow employees to create documents, share information, and collaborate on projects that is work over common documents irrespective of device or location. Now, let us see how does a web application work.
Web application needs a web server for managing requests from the client. It also requires an application server for performing tasks requested and at times a database to store information. Here is how a web application works. Web application flow starts when a user makes a request through a web application on the internet. The request is sent to the web server. The web server forwards the request to the specific web application server, which in turn performs the requested task that includes processing data and querying database. The web server then replies to client with necessary information, which is displayed to the user in the browser. Example of a web application. Web applications comprise of email programs like Yahoo and Gmail, Google Apps, and Microsoft 365. Let's learn about the advantages of web applications. Web applications run on numerous platforms, irrespective of the device or OS, until the browser gets compatible. All users get access to same version, thus avoiding any issues of compatibility. Web applications are accessible anytime, anywhere, and via any PC with an internet connection. Installation and maintenance are less complicated as new version or upgrade is installed on the host server, allowing all users to access the application straight away, and there is no need to upgrade the PC of every user. Thus, it is highly cost-effective. Here is the typical structure of a web application. As discussed earlier, a web application can be accessed by users through a web browser or a specialized user agent. The browser creates HTTP requests for specific URLs that map to resources on web server. The server renders and returns HTML pages to the clients, which the browser can display. A typical example is a three-layered architecture that comprises presentation, business, and data layers. The figure illustrates a typical web application architecture with common components grouped by different areas of concern. Presentation layer usually includes UI and presentation logic components. It facilitates user interaction. The business layer usually includes business logic, business workflow, and business entities components, and optionally a facade. The business layer for web application gets displayed. Consider how long-running workflows and business logic gets implemented. The data layer usually includes data access, and service agent components. Let's discuss the design layers of web application architecture in detail. Presentation of the web application shows UI and facilitates user interaction. In this layer, the application shows to the user what is needed to be seen and gives the tools for interaction. The presentation layer includes the two types of software components that perform specific tasks. They are UI components and UI process components. There are several key factors that you should consider when designing the presentation layer. Design is focused on the separation of different concerns and user interaction logic gets decoupled from UI components. It is advisable to use different UI components and the presentation logic components in the complex interfaces. Base the UI components on the standard web controls where that is possible. Compile the controls into assembly for use across applications. Presentation layer of web application comprises two components. They are server-side components and the client-side components. All presentation logic is in server components, and client components display HTML. With client-side scripting like AJAX, the user experience can be improved by executing logic on client-side. Business layer of the web application consists of the following components: application facade, business components, business entities. Various factors are considered while designing a business layer. Design the business layer for being stateless that helps in reducing resource contention and increase the performance, and consider making use of interface that is message-based. Design business entities which represent real-world data and use them for passing data between components. It is always good to use a separate business layer where possible to improve the maintainability of your application. The data layer may contain the following components: data access components and service agents. There are many key factors that you should consider while designing the data layer. Data layer is designed for the web application, which abstracts logic necessary for accessing database. Use a separate data layer for the application for easy configuration and maintenance. Entity objects should be designed to update the data source and use the data transfer objects for interacting with other layers and passing data between layers. Design the data layer in such a way that it takes the advantage of connection pooling to minimize the number of open connections, and consider using batch operators for reducing round trips to the database. Use service agents to access external services. If you're planning to deploy the business layer on remote tier, or if there is a plan of exposing the business logic with web service, it is good to design different service layers. Design services to achieve better usability. It is good to implement various interfaces, versions, to allow a client to connect with appropriate version. If the business layer is on the remote tier design, then the service methods that are coarse-grained for minimizing count on round trips. It also provides loose coupling. Ensure to implement business rules in the service interface, which makes it difficult for keeping interface stable and generates unnecessary dependencies for clients and components.
Web 2 is described as a changing trend in the worldwide web technology and web design. It provides an infrastructure with more dynamic user participation, enhanced social interactions and collaboration. It also provides improved creativity, secured information sharing, and a much intensified collaboration. It's the new version of www without changing any actual technical specifications. Web 2 have led to the introduction and evolution of web-based communities and hosted services like Facebook, MySpace, video sharing sites as YouTube, wikis, blogs, etc. Now, let's learn about the usage of Web 2. Some of the usage of Web 2 are interoperability. It is the ability of Web 2 to communicate and work side by side with other applications that may not be of the same platform, enhancing the quality of the information. It is widely used in advanced gaming, dynamic site content, and RSS-generated syndication. Interactive data sharing. It is the resourceful collection of information that helps in direct communication between machine and humans. Interactive data sharing is widely used in Google-based and other free web services like Google Maps, search engines like Yahoo, AOL, and MSN, and encyclopedias and dictionaries. Collaboration on the web. This is referred as working together to attain a common defined goal. Web 2 provides a platform where the end users can collaborate with an organization to work together to reach a goal of shared interest over the internet. Wikis, blogs, social networking sites, and mashups like emails, IMs, electronic payment systems are some of the collaborative approaches of Web 2. User-centered design. User-centered design is a framework used to define the goals, user characteristics, environment and tasks, workflow of a product and service or process. It is used for ease of data creation, modification, or deletion by the end user, and in online office software like Google Docs and Microsoft SLATES.
Here are a few features of Web version 2. Salient features of Web version 2 are coined by Andrew McAfee and is referred as acronym SLATES. They are search, links to other websites, authoring, tags, extensions, signals. Search. It helps in finding any form of content over internet with the help of keywords. Links to other websites. They help in guiding the user to link to frequently used pieces of information. Authoring. It provides the users to redo or undo the content in order to provide others with the correct facts and data. For example, in Wiki, users can modify the interactive context for the better information delivery. Tags. These are helpful in categorizing posts, videos, photos, and contents over huge mass, with simple one-word descriptions to enhance the end user with the ease of searching and avoiding the burden of rigid, pre-made categories. Extensions. These are the software that make the web an application platform as well as a document server. For example, Amazon.com recommendations. Signals. They provide the user with the syndication technology where the intimation of data changes can be notified. For example, RSS, really simple syndication feeds, allow users to access the updated contents over the web page. What is vulnerability? Vulnerability refers to the flaw in system which compromises the security of the web page and exploits the digital security of the end users. According to a recent survey, there are 8 out of 10 websites that gets compromised, resulting in cybercrime, financial loss, lack of authenticity of the genuine users, brand damage, and theft of intellectual property. Vulnerability stack represents the areas of focus where the possible vulnerabilities can occur. It is represented in 7 different layers as seen in the image. They are customs web applications, third-party web applications, web server, database, applications, operating systems, networks.
So far, we have learned about network scanning and ethical hacking. Let's check your understanding of this section. What does the acronym SLATES stand for? SLATES is the salient features of Web 2, coined by Andrew McAfee, that stands for the features search, links to other websites, authoring, tags, extensions, and signals. The number of internet users have increased rapidly since the birth of the World Wide Web, which in turn have resulted in the deployment of more web applications. Web application provides services that have huge databases of different categories of the people over internet. Since the web applications are widely accessible to the internet, it eventually produces a very large number of potential attackers. This module discusses different kinds of threats that exist in web applications.
Today, most security breaches online occur through the application rather than the server. Web applications has become a very attractive target for attackers. Some of the common web application threats are unvalidated input, parameter form tampering, directory traversal, security misconfiguration sample, cross-site scripting, injection flaws, denial of service attack, buffer overflow attacks, cookie session poisoning attack. Let us discuss these web application threats in detail.
Web applications use input from HTTP requests to determine how to respond. To bypass the security mechanisms of websites, attackers can tamper any part of an HTTP request, including the URL, query string, headers, cookies, form fields, and hidden fields that results in invalidated inputs. When the input is not validated before being processed by the web applications and the backend servers, attackers can exploit the input validation flaws to perform cross-site scripting, injection attacks, buffer overflows, etc. on a wide level, resulting in data theft and system malfunctioning. Web parameter tampering attack occurs when the client and server exchanges parameters to modify application data, such as user credentials and permissions, price and quality of products, etc. Parameter tampering attack is performed by the malicious user who wants to exploit the information stored in cookies, hidden from fields, or URL query strings of the web application for his or her benefits. This attack exploits the vulnerabilities, integrity, and logic validation mechanisms that results in cross-site scripting, SQL injections, etc.
Directory traversal, also known as path traversal, is an HTTP attack which allows attackers to access restricted directories and execute commands outside of the web server's root directory. Web servers provide two main levels of security mechanisms: access control lists, ACLs, and root directory. An access control list is used for authorization process, whereas the root directory is a special directory on the server file system in which the users are restricted. Users are not allowed to access anything above this root. Directory traversal attack occurs when an attacker tries to exploit the HTTP and gains access to these restricted directories and is able to execute commands outside the web server's root directory. Security misconfiguration vulnerabilities occur when attackers gain unauthorized access to default accounts, read unused pages, and exploit some of the unpatched flaws. This is the most common threat to web application. When there is a configuration mistake in the web application, attacker takes full control over the web application, which may lead to theft of sensitive data and top priority information. For example, if a system admin forgets to delete a default account which holds the admin privileges, then the attacker can easily Google the default credentials and take charge of that account. Injection flaws are those web application vulnerabilities that allows untrusted data source to be interpreted and executed as a part of command or query string. Your web application becomes vulnerable when attackers break out the web application context and insert malicious commands and queries, resulting in data loss or corruption and denial of access or lack of accountability. There are many kinds of injection flaws, and some of them are SQL injection attacks, command injection, LDAP injection. Let's learn about the injection attacks in detail. In SQL injection or SQLI attack, an attacker executes malicious SQL statements that control a web application's database server. An attacker uses a normal web application, which is vulnerable, and bypasses the security levels to obtain direct access to the vulnerable data stored in it. This attack is known as one of the most vulnerable and dangerous web application threats, as it could affect any website or web application by bypassing authentication and authorization measures. SQL injection attacks can also be executed from the address bar, from within application fields and through queries and searches. Command injection attacks occur when an application passes unsafe user-supplied data, such as forms, cookies, HTTP headers, etc., to a system shell. In this, the attacker tries to execute the arbitrary command on the host operating system via a vulnerable application. It can be of any form, such as shell injection. In shell injection, attacker tries to input a string crafted to gain shell access to a web server. Some of the shell injection functions are system, start process, Java language runtime, exec, system, diagnostics, process.start, and similar APIs. HTML embedding. In this, an attacker generates the threat in web application with the help of an extra added HTML-based content. File injection. In file injection, attackers inject malicious codes to the system files by the attacker, exploiting the web application. Let us now discuss few examples of command injection attack. In this example, an attacker tries to enter the malicious code I.E. account number with a new password. The last two sets of numbers are called the banner size. After entering the details, when the attacker hits the submit button, the password of account 1005 gets changed to new password. Servers assume that only the URL of the banner image is inserted in the banner URL field. LDAP stands for Lightweight Directory Access Protocol, which is an open standard protocol that queries and manipulates X version 500 directory services. The LDAP runs over transport layer of internet like TCP. LDAP injection attacks are almost similar to SQL injection attacks. The difference lies with the LDAP queries that are generated for this purpose instead of SQL queries. The attacker sends a query to the server for generating an invalid input, for checking whether the application is vulnerable to that LDAP injection code or not. If the LDAP server returns an error, then it can be exploited with the code injection techniques. There are some web applications that embed hidden fields within the web pages to hack and pass the state information between the web server and the browser. The syntax of hidden field in web form is represented as shown in the screen. But if the developer provides the confidential information, such as some sensitive data related to the pricing and quantity of the products of any e-commerce website in the hidden field tag, instead of storing in a back-end database, the attacker can examine the HTML code of the page and change the hidden field values. Cross-site scripting is a common web application attack used to gain access to private information by delivering malicious code to end users via trusted websites. Unlike other web attacks, in CSS, users are at risk rather than web applications. Cross-site scripting occurs when an invalidated input data is included in dynamic content that is sent to a user's web browser for rendering. Cross-site scripting attack can lead to devastating consequences to the reputation of online business and the relationship they have with clients. CSS attacks are classified into two: stored XXS and reflected XSS. Stored XXS, also called as persistent XXS, happens when malicious scripts get injected directly to vulnerable web application and is highly damaging. Reflected XSS has reflecting of malicious scripts off the web application onto the browser of the user. Script gets embedded to link and is activated once the link gets clicked on. Let's see how a perpetrator executes stored XSS attack. To execute a stored XSS attack, perpetrator should locate vulnerability in the web applications. The perpetrator then injects malicious scripts to the server. The common targets of these attacks are websites, which allows the users in sharing content that includes video sharing platforms, social networks, blogs, and message boards. Whenever the user views the infected page, the malicious script gets transmitted to the browser of the victim. Thus, visitor's session cookie is sent to the perpetrator. How can we prevent stored XSS attack? Stored XSS attack can be prevented by using web application firewall. Different methods are employed by WAFs for counter-attacking vectors. Web application firewall of Imperva in CAPTCHA employs a signature filter for countering cross-site scripting attacks. Crowdsourcing is another approach that provides extremely rapid response towards zero-day threats. Protects entire user community against new threats whenever one attempt for attack is identified. Crowdsourcing also allows usage of IP reputation system, which blocks repeated offenders that include botnet resources that may be reused by numerous perpetrators. Let us now learn how to prevent stored XSS attack. How can we prevent stored XSS attack? Web Application Firewall, or WAF, is the most common solution used to protect web application from XSS attacks. Different methods are employed by WAFs for counter-attacking vectors, such as filtering based on the signature for identifying and blocking malicious requests. As per the best practices in industry, Web Application Firewall of Imperva in CAPTCHA employs a signature filter for countering cross-site scripting attacks. It is managed service maintained by a team of security experts who updates the security file constantly with the signatures of the new discovered attack vectors. CAPTCHA crowdsourcing technology collects and aggregates attack data automatically from across the network for the advantage of the customers. Crowdsourcing approach provides extremely rapid response towards zero-day threats and protects entire user community against new threats. Crowdsourcing also allows usage of IP reputation system, which blocks the repeated offenders that include botnet resources that may be reused by numerous perpetrators. Let us now discuss some of the common scenarios of CSS. Some of the common scenarios where the XSS attacks are most vulnerable to happen are XSS attack via email, XSS attack by stealing users' cookies, XSS attack by sending unauthorized requests, XSS attack in blog posting, XSS attack in comment field. The figure shows the steps involved in XSS attack via email. The attacker tries to craft an email message with a malicious script and then it sends to the user. The user clicks on the link and the URL is sent to the fake website that has been created by the attacker. The user then provides the financial details and it reveals all the personal information to the attacker, This compromises the integrity of the user's account information. The figure shows the steps to perform the XSS attack by stealing the user's cookies. The attacker hosts a malicious web script. The legitimate server views the page hosted by the attacker. The web server then redirects the HTML page, which contains the malicious script, to the victim. When the victim runs that page, the malicious codes get the user's information. The user's cookie information, such as saved passwords, frequently visited sites, etc., are collected. This is redirected to the attacker. The attacker then sends the requests with the user's cookie by impersonating him, and the legitimate server serves the request sent by an attacker. An unauthorized request is the one which does not hold any validity over the user's data. The image here shows an access performed using unauthorized requests. The attacker creates a malicious link on the website. The URL of the link is sent to the victim through email. This email convinces the user to click on the link by luring them of great deals and offers. When the user clicks on the link, a request is generated and sent to the legitimate server. The page with malicious script is reverted from the server back to the user's browser. The user then runs the malicious script. The malicious code is sent as an authorized request to the server, and the server serves the request by thinking it as a genuine request. Blog posting is a very common approach which helps the user in providing comments and feedbacks to any of the genuine websites. The attacker can use these blog posting sections to invade XSS attack in the websites as shown in the image. In this approach, an attacker adds a malicious script in the blog post section of any website. The database server stores all the blogs along with the malicious links. When the user visits those websites, he comes across the blog posting sections. The user, when clicks on these links, gets redirected to the infected web pages. An alert pops up when the link is clicked. Thus, this successfully affects the user's account in that website. This approach is similar to the blog posting, except the attacker posts a malicious link in the comment section of the blog post, despite posting in the blog section. In cross-site requests forgery attack, end user is forced to execute unwanted actions on a web application in which they are currently authenticated. A successful CSRF attack can force the user to perform state-changing requests, for instance, transferring funds, changing their email addresses, and so on. Denial of service attack occurs when the attacker tries to prevent the user from accessing the information from any web application or to use any services over that web application. The attacker targets the computer the user relies on and prevents them from using the services they frequently access, like emails, online transactions, etc. In a DOS attack, the attacker usually sends excessive messages to flood servers, systems, or networks with traffic in order to overwhelm the user's resources and making it difficult or impossible for legitimate users to use them. Common examples of DOS attacks are user registration DOS, login DOS attack, user enumeration attack, and account lockout attack. In user registration DOS, attacker creates an intensive form registration requests that creates spurious user for a single user registration form. Thus, the server gets flooded with the malicious registration forms and denies the authentic user's form. Login DOS attack occurs when the attacker sends thousands of login requests to the server, which results in malicious requests, thus making it unavailable for the authentic user, or the server might get reasonably slow to respond. In user enumeration attack, the attacker tries the common usernames and password combinations from a dictionary file to enumerate the users of an application, resulting in user enumeration attack. In account lockout attack, the attacker may enumerate the usernames and attempt to authenticate a malicious username and password combinations, which is incorrect and blocks the user account. Buffer overflow attack occurs when an application writes more data through a block of memory or buffer than it can actually handle, causing data to overflow into adjacent storage. Almost all known web servers, application servers, and web application environments are susceptible to buffer overflows. C and C++ platforms are also more susceptible to buffer overflow. What are cookies? Cookies maintain bits of information that allow websites you visit to authenticate your identity, speed up your transactions, monitor your behavior, and personalize the presentations for you. However, cookies are also targets for attackers. Cookie poisoning provides an attacker the ability to modify valid cookie and gaining false authorization for information related with another user and stealing the information. Cookie poisoning is a deceiving and tricky attack. Numerous web applications make use of cookies for saving user information like account emails, passwords, and logins. Cookie poisoning attacks modifies the contents of a cookie, which bypasses the security mechanisms. Attacker injects malicious contents and modifies the user's online experience, which makes him gain the unauthorized access of the user's account. Next, let's discuss how cookie poisoning works. To understand the working of cookie poisoning, let us take an example. Here, the user is trying to request an online transaction from the web server of an e-commerce site, and an attacker intrudes between the request-response sessions and performs cookie poisoning. Let us discuss the process in step by step. The user is trying to do an online shopping over an e-commerce site. During this process, an HTTP request is sent to the web server to display a particular web page on the internet. The web server takes the URL requested by the user and replies with the requested page and simultaneously saves the cookies on the user's browser, so as to maintain the session state. Here, in the given cookie, the user is trying to buy some item from an e-commerce site, for instance www.xyzcommerce.com. The basket size equal 4 is given, which means there are 4 items added in the e-cart along with the product or item code. Also, the session ID is also generated. At this point, the attacker steals the cookie by phishing attack and modifies the cookie data. Attacker modifies the address of the user and orders for the product using modified cookies as shown here, and sends the request to the web server. Attacker changes the item code and it results in changing the items of the order, and the total price also varies. Attacker can also change the delivery address, and the address gets delivered to the attacker's destination. In session fixation attack, the attacker tricks the web user to access a genuine web server using an explicit session ID value. At the server side, the attacker exploits the user's credential, and this leads to the misuse of the authorized credentials by the attacker. Despite of having strong user authentication and active session management, attacker can break into the web application security system and damage forgot password, incorrect user IDs, remember my password, update accounts, and other credential management fields. Attacker can gain access to user's account and can impersonate to steal the account details. Few examples of the broken authentication attack are session ID in URLs. Attackers trick the user to get the session ID and reuses it for malicious purposes using the network traffic. Password exploitation. Attackers can breach the web application's password database to gain access to the entire user's account and can exploit their passwords. Timeout exploitation. When the user simply closes the browser without logging out while accessing through a public computer, and if the application's timeout is not set properly, then the attacker can use the same browser later and exploit the user's privileges. Completely automated public turn-in test to tell computers and humans apart, or CAPTCHA, is used by many web applications to ensure that the response generated is by humans and not by computers. It ensures that the applications are being validated by humans, and it helps in avoiding the system from unauthorized access and abuse. However, attackers can exploit the CAPTCHA images and text and make the system vulnerable by compromising its security. Various types of CAPTCHA attacks are breaching client-side trust, manipulating server-side implementation, and attacking CAPTCHA images. Let us discuss a few more web application vulnerabilities. As you all know, an application vulnerability is a system flaw or weakness is an application that could be exploited to compromise the security of the application. Most common application vulnerability are insufficient transport layer protection, improper error handling, insecure cryptographic storage. Insufficient transport layer protection occurs when web applications do not take any proper security measures to protect network traffic. It supports weak algorithms and uses expired or invalid certificates, leading to launch attacks. Improper error handling occurs when the errors are handled in an improper fashion. A lot of the security problems for websites is generated. Improper error handling provides insight into the source code, helping the attacker to identify the existing vulnerability and launching various web application attacks. The attacker can thus gather information about the web applications like null pointer exceptions, system call failures, unavailability of the database, network timeout, etc. Insecure cryptographic storage occurs when sensitive data is not stored securely. To avoid this vulnerability, developers should identify all sensitive data and encrypt that data. Unvalidated redirects and forwards occur when a web application accepts the untrusted inputs without checking the credibility of the inputs from the user, allowing to redirect and forward the user's active request response sessions to other web pages. Hence, redirecting the user to some malicious websites or can forward them to access unauthorized pages. Unvalidated redirect occurs when the attacker sends an email to the user containing the rewrite link to malicious server, hence redirecting the user to the malicious websites. Unvalidated forward occurs when the attacker requests a web page from the server with a forward link. The attacker is forwarded to the admin page. Web services are XML-based information exchange systems that make use of Internet for directing application to application interaction. These systems include objects, messages, documents, or programs. The web services architecture provides a common definition of web services along with the framework and their defined components. The web architecture represents the minimal characteristics common to all web services. All the global components and their interconnectivity with their goals are defined in it. The image on the screen shows the web services architecture stack. The main global components of the web services are Simple Objects Access Protocol, SOAP, Universal Description, Discovery and Integration, UDDI, Web Services Description Language, WSDL. Let us now discuss the roles of web service architecture. There are three major roles of web service architecture. They are service provider, service requester, and service registry. Service provider provides the web service from clients to user and is used to implement the service to make it available for the user on the Internet. Service requester is any user on the Internet who wants to access the web service. The user utilizes any existing web service by opening a network connection and then sending an XML request to the server. Service registry is a logically centralized directory of services which provides a central place to developers for publishing new services or finding existing ones. Next, we will learn about web services attacks. Web services attacks usually occur at different layers of web architecture. As web-based services are based on XML protocols, WSDL for describing the connection, UDDI for the description and discovery of web services, and SOAP for communicating between web services, then some of the layers web applications are vulnerable to threats and attacks. The table on the screen shows the web services stack and the possible attacks that can compromise the web application.
What is XML poisoning? XML poisoning refers when attackers inject malicious XML codes to SOAP requests to accomplish XML not manipulation or XML schema poisoning for generating errors in XML, parsing logic, and breaking execution logic. XML poisoning allows the attackers to cause denial of service attack, which compromises the user data integrity and the security of the web services. In this section, we have learned about web application threats and vulnerabilities. Now, let's check your understanding. Name any 4 web application threats. Some of the web application threats are parameter form tampering, directory traversal, security misconfiguration, cross-site scripting.
There are various web application hacking methodologies that are used. They are footprint web infrastructure, attack web servers, analyze web applications, session management attack, perform injection attacks, attack data connectivity, attack web app client, attack web services. Let's discuss each one of these methodologies in detail. Footprint web infrastructure is the first step to web application hacking. As the name suggests, this process discovers, identifies the web infrastructure. This helps to choose the victim and find vulnerabilities. There are 4 components of footprint web infrastructure. Server discovery. It helps in discovering the physical servers that hosts web applications. Service discovery. It discovers services which run on the web servers that are vulnerable to exploitation through web app hacking. Server identification. Server banners are grabbed to identify the manufacturer and versions of the web server software. Hidden content discovery. It extracts the contents and functionalities that are not directly linked and are unreachable from the main visible content. After the web server's environment is identified, the server is scanned for any known vulnerabilities using a web server vulnerability scanner. The web server attack is launched to exploit these identified vulnerabilities. Some of the tools that are used for web application security scanning are URL scan, Nikto, Nessus, Acronym web vulnerability, and Web Inspect. Let's discuss the tool Web Inspect 9.10 in detail. Web Inspect is HP's web application security scanning tool. It is helpful for the security professionals to assess any potential security flaws in web applications. The tool performs a scan with the help of assessment agents that work on various areas of the application. A vulnerability assessment report is generated that lists the security issues in the desired format. With the report, the issues are fixed and sent for validation scanning to confirm the changes. HP Web Inspect is a commercial tool and needs a valid license to be used. There are some advantages and disadvantages in this tool. Advantages of the tool: saves time while handling large enterprise applications, simulates the attack, shows the results and then presents a comprehensive view. It is not dependent on the underlying language. Disadvantages of the tool: like any other tool, this tool may not find logical flaws, weak cryptographic storage, severity of the disclosed information, etc. It has a list of the payloads which is used for every web application. It does not generate payloads according to the kind of application. There might be false positives among the listed vulnerabilities. The functionality and the technology of an active web application is analyzed to find any attack surfaces that can be vulnerable. There are 4 components that are important in analyzing. Identify entry points for user inputs. Identify server-side functionality. Identify server-side technologies. Map the attack surface. Let's discuss each of these components in detail. Identify entry points for user inputs. The generated HTTP requests are reviewed to identify all user input entry points. The HTTP header, URL, cookies, post data, and query string parameters processed by the application are examined. Any customized data transmission or encoding mechanisms implemented for securing web traffic like SSL are identified. Identify server-side functionality. The applications which are revealed to the clients are observed to identify the server-side structure and functionality. The core functionality of the application is determined. All the core security mechanisms, particularly the session management, access control, and support functions like user registration and account recovery, is understood. Identify server-side technologies. The various technologies used on both client and server-side, including scripting languages and back-end components like database, are identified. A detailed fingerprint technique, such as HTTP fingerprinting, is run. The URLs for file extensions, directories, and the error messages that are notified on the web application's pages are examined. Map the attack surface. Various attack surfaces in the applications and the vulnerabilities that are associated with each one of them is understood. A brief description of the components of the application and its vulnerable attack is listed in the table. In this mechanism, the attacker exploits the design and implementation flaws of the web application, like failure to check password lengths or insecure transportation of credentials. Some of the authentication mechanism attacks in the web app hacking methodologies are username enumeration, password attacks, session attacks, cookie exploitation. Let's discuss each one of these in detail. Username enumeration. In this method, the attacker tries to guess the combination of the username and the password through trial and error method. Some web applications reveal if the username exists or if the password is wrong. This allows the attacker to determine the patterns and enumerate valid users. There are 2 types of username enumeration strategies: verbose failure messages and predictable failure messages. Password attacks. Password functionality exploits, password guessing, and brute forcing are some ways of password attacks. In case of the Remember Me cookie, an attacker makes use of enumerated username or predict session identifier. The password changing and password recovery can also be misused by the attacker to guess a combination of old and new password or answer the challenge question. Password guessing is possible through manual process and automated tools like THC Hydra, Burp Intruder, Brutos, and WebCracker. In the brute force attacks, attackers crack login passwords by trying with possible values from different sets of special characters, numbers, and alphabets. Session attacks. In this method, the attacker tries to guess the session ID values to bypass the authentication process of a web application. Some valid session ID values are first captured by sniffing the traffic and then analyzed to understand the session ID generation process. The structure of the session ID, the information that is used to create it, and the encryption or hash algorithm used by the application to protect it is studied. Some vulnerable session ID values use a combination of timestamp or client IP address and username. These can be easily exploited. Brute force technique can be implemented to generate and test various values of the session ID until the access to an application is obtained successfully. Cookie exploitation. Cookie poisoning is a way of stealing the cookie information and modifying it before it is sent to the web server. The attackers use eavesdropping or injections to steal the cookie information, which contains passwords or session identifiers. They will then replay the cookie with altered or same passwords, the session identifiers, to bypass web application authentication. An application session management mechanism is very important and is usually the top target for attackers. If an application session management is broken, an attacker can completely bypass its authentication, controls, and pretend as other application users without knowing their credentials. A session token is generated by the server for every session of a user and sent to the client as a cookie. The session tokens tampering and session tokens predictions are the session token generation attacks. Session hijacking, session replay, and man-in-the-middle attack are session tokens handling attacks. In the session token generation attacks, the attacker can either predict the session ID values easily by analyzing a group of session ID values generated, or tamper the session ID by changing the value, date for another transaction. In the session token handling attacks, the attackers take advantage of the encrypted and encrypted form of session tokens and gain access to it. Then the attackers replay cookie for gaining unauthorized application access. In injection attacks, the attacker crafts malicious inputs to intentionally confuse and break the normal intent of the application. Some of the common injection attacks are listed and briefly explained. I will pause this screen for you to read it. The database connection strings are meant to connect applications to their database engines. An example for common connection string can be data source equal server, port, network, library equal dbm ssocn, initial catalog equal database, user ID equal username, password equal pwd. Database connectivity attacks exploit the way applications are connected to the database rather than abusing the databases. Connection string injection. The attacker injects parameters in connection strings by appending them with the semicolon character. This attack occurs when a dynamic string concatenation is used to build connection strings based on user inputs. Connection string parameter pollution, CSPP. The attacker overwrites parameter values in the connection string with the desired value by any of these methods. Hash stealing. Attackers get parameter value overwritten in the connection string. The data source parameter's value is replaced with the rogue Microsoft SQL server connected to the internet running the sniffer. Port scanning. The port to connect to is one of the valid parameters of the connection string. The attacker can abuse an application to network scan servers by trying to connect to different ports and see the error messages obtained. The error messages are then analyzed for differences and a port scan is run. Hijacking web credentials. The attacker here connects to the database with the web application system account instead of a user's credentials. Connection pool DOS. The attacker here understands the connection pooling settings of the application and constructs a large malicious SQL query, and runs multiple queries simultaneously to consume all the connection in the connection pool, making the database queries for legitimate users to fail. The client-side attacks are different from server attacks. Here, the attackers target the vulnerable client's applications on the server to perform malicious actions against end users and access their data. Some of the types of web app client attack listed. I will pause a few minutes for you to read. The web services work with numerous legacy web applications, and an attack on the web services will immediately expose the logic and business vulnerabilities of the application. The various kinds of attacks on web services are WSDL probing attacks, XML injection, and SOAP injection. Let's discuss a little about each of these attacks. I will pause a few minutes for you to read.
Hacking tools are necessary to hack the web application. There are many hacking tools available that make the life of a hacker easy by automating the tasks. Here, we are going to discuss the concept of hacking tools and their functionalities.
Barb Suite Professional is a web application scanner that finds the security vulnerabilities in web applications. It is mostly used by the security testers to serve the existing technologies and methods so that a manual and semi-automated penetration testing approach can be availed by the users. It can also be used to automatically detect SQL injection vulnerabilities. It is a good tool to use both under Windows and Linux environments. The image here shows the payload positions of Barb Suite Professional. Cookie Digger is a tool used to identify weak cookie generation and insecure implementations related with session management by the web applications. This tool works by collecting and analyzing cookies issued by a web application for various users. The tool reports on the predictability and entropy of the cookie and whether critical information such as username and password are included in the cookie values. WebScarab is the framework to analyze applications that are communicated with HTTPS and HTTP protocols. It is written with Java, and so it is portable and platform independent. WebScarab comes with various modes of the operation implemented with numerous plugins. WebScarab works as intercepting proxy in the common usage. It allows operator to review and modify requests which are created by browser before that reached server and review and modify responses that come from the server before reaching browser. It is capable of intercepting HTTP and HTTPS communication. The operator can review conversions passed through WebScarab. Let us now learn about different types of countermeasures that are available to defend various types of attacks. In web applications, different types of encoding schemes for the data are involved to safely handle unusual characters and binary data in the way the user intends to be used. Some of the types of encoding schemes are URL encoding. It is the process of converting URL into valid ASCII format so that the data can be safely transmitted over the HTTP request. HTML encoding. This scheme used to represent an unusual character so that they can be safely combined within HTML documents. Unicode encoding. There are two types of Unicode encoding. There are 16-bit Unicode and UTF-8. 16-bit Unicode replaces the unusual Unicode characters with unsigned integer, which is followed by the characters Unicode code points expressed in hexadecimal. UTF-8 is a type of variable length encoding standard scheme which uses each byte expressed in hexadecimal and preceded by the %sign prefix. Base 64 encoding. This encoding scheme represents any binary data using only the printable ASCII characters. Hex encoding. It is an HTML encoding scheme that uses hex values for every character to represent a collection of characters for transmitting binary data. Next, let us learn how to defend against various web application attacks. SQL injections can be defended by limiting the length of the user input. Use custom error messages, monitoring DB traffic with IDS, WAF, disabling commands such as xp-cmd shell, isolate database and web server, use method attribute set to post, and lower privileged account for the DB connection, run database service account that has minimal rights, move extended stored procedures to isolated server, use type-safe variables or functions like isNumeric for ensuring type safety, and validate and sanitize the user inputs that are passed to database. We can defend against common injection flaws by performing input validation, escaping dangerous characters, using libraries that are language specific so that they avoid problems because of shell command, performing input and the output encoding, user-safe API that avoids usage of interpreter. Requests should be structured for treating the supplied parameters as data than content that is potentially executable. Usage of parameterized SQL queries and usage of modular shell disassociation from kernel. XSS attacks can be defended in many ways. It can be done by validating the headers, hidden fields, form fields, query strings and cookies, using the web application firewall for blocking execution of the malicious script, encoding the output and input, and then filtering the meta characters and input, filtering script output for defeating XSS vulnerabilities so that they can be prevented from getting transmitted to the users, using the testing tools well during design phase for eliminating XSS holes in application before that is used. It is not advisable to trust websites with HTTPS. Developing signing or standard scripts that have public or private keys for actually asserting whether script introduced is authenticated. DOS attacks can be defended by configuring firewall for denying access of external Internet Control Message Protocol traffic, securing remote administration, and the connectivity testing, preventing usage of unnecessary functionalities like return addresses, form overwritten, strcpy and gets, preventing overwriting of sensitive information, performing input validation thoroughly, and stopping data processed by attacker from execution. You can defend against web services attack using several ways. Few methods to defend the attack are: configure WSDL access control permissions for granting or denying access to any kind of SOAP messages that are based on WSDL. Make use of the authentication credentials that are document-centric, which uses SAML. Use the multiple security credentials like WS Security, SAML assertions, and X509 cert deploy firewalls that are capable of ISAPI and SOAP level filtering. Configure the firewall's IDS system for signature detection and web services anomaly. Configure IDS systems or firewalls for filtering improper XML and SOAP syntax. Implement centralized kind of inline responses and request schema validation. Use prefetched content while dereferencing URLs and blocking external references, and update and maintain the XML schemas of secure repository. As we all know, attackers can exploit the CAPTCHA images and text and make the system vulnerable by compromising its security. However, there are many ways to secure CAPTCHA implementation. They are: clients should have direct access to the CAPTCHA solution. No CAPTCHA reuse and then present the randomly distorted CAPTCHA image text to user. Use the CAPTCHA implementation that is well established, like reCAPTCHA, other than creating their own CAPTCHA script, and then allow users to choose audio or the sound CAPTCHA. Wrap the individual letters so OCR engines are unable to recognize them. Include the random letters in security code for avoiding dictionary attacks. Encrypt the communications between CAPTCHA system and website. Use different fonts inside CAPTCHA for increasing complexity of the OCR engines for solving CAPTCHA, and make use of authentication credentials. Let us now learn about the web application attack countermeasures used to secure the systems and their web application. As you all know, with the emergence in the technologies, there is an increase in web application vulnerabilities and the threats associated with them. When hackers come up with new ideas and vulnerabilities to attack the web application, the developers also come up with new countermeasures to secure the systems and their web applications. Countermeasures used to prevent the following web application attack are: unvalidated redirects and forwards can be avoided using forwards and redirects. If the destination parameters are not avoided, ensure supplies value is not authorized or valid for users. Cross-site request forgery. To prevent cross-site forgery, log off immediately and do not allow the browser and website to save login details. Check HTTP referrer, header, and process posts and ignore the URL parameters. Broken authentication and session management and be avoided by use SSL for the authenticated parts of application. Verify if users' identities and credentials get stored in the hashed form. Never submit the session data with the post and get. To avoid insecure cryptographic storage, create and use weaker cryptographic algorithms. Generate the encryption keys offline and store it securely. Ensure that the decryption of the encrypted data stored on the disk is not easy. Directory traversal is avoided by defining access rights for protecting areas of website. Apply hotfixes or checks which can prevent exploitation of vulnerability like Unicode for affecting directory traversal. Ensure timely update of security patches of web servers. Cookie session poisoning. Do not store plain text or the weakly encrypted password in the cookie. Implement timeout of the cookie. Authentication credentials of the cookie should be associated with IP address. Apply logout functions. Security misconfiguration. Configure the security mechanisms and turn off the unused services. Set up permissions, accounts, and roles, and then disable the default accounts or change the default passwords. Scan the latest security vulnerabilities and apply latest security patches. LDAP injection attacks are prevented by performing the domain value, pattern, and type validation on the input data. Making LDAP filter specific. Validate and limit the amount of the data redirected to the user. Implement tighter access control and data in LDAP directory. Perform dynamic testing and analysis of source code. File injection attack. Strongly validates the user input. Consider the implementation of crude jail. How can we defend against web application attack? We can defend against web application attack by using intelligent web application firewall to shield the vulnerabilities, work with behavioral firewall or for blocking dangerous and sophisticated attacks, using well-reviewed and reliable DDoS protection tool to prevent DDoS attacks, clearing the stored cookies from the browser regularly, carrying out malware and regular virus scanning. Let us now learn about different types of security tools for web application. What is a web application security tool? Web application security tool, or scanner, is a program tool that scans web applications to identify the possible security threats through web front end. These vulnerabilities may occur in the web application's framework or its architecture. These scanners do not access the source code. There are many web application security tools used nowadays. A list of web application security tools is shown in the next screen. Here is a list of web application tools available nowadays. Various paid and free web application security tools are available. I will pause for a few seconds to allow you to go through the list. Now let us discuss more about some of the web application security tools. Accunet is the pioneer in automated web application security testing with innovative technologies that includes deep scan technology for crawling AJAS, heavy single-page applications of client-side, most advanced SQL injection in the industry, and cross-site scripting testing with DOM-based XSS advanced detection. AccuSensor Technologies combines the black box scanning techniques with the feedback from the sensors placed within source code. The features that make Accunet Web Vulnerability Scanner popular are: it is fast, accurate, and easy to use. It has the highest detection of WordPress vulnerabilities, as it can scan WordPress installations for over 1,200 known vulnerabilities in WordPress core, themes, and plugins. Accunet has an easy-to-use login sequence recorder that allows the automatic scanning and complex password-protected areas. It has built-in vulnerability management to review vulnerability data. WebWatcher Security Tool is initially a Fiddler add-on, which aims to assist the penetration testers to find web application vulnerabilities in a passive form. It provides great levels of securities and also the hotspot detection techniques, helping the pen testers to focus on the spots that lead to exploits. Some of the reasons to use WebWatcher are because of the following features: secure for cloud and hosting environments. Since WebWatcher is a passive tool, it serves as a great advantage for those applications which are cloud-based and have often high risks of security testing that can damage the shared infrastructure. Being a passive tool, WebWatcher ensures that there is no chance of damaging the cloud-like infrastructure. Secure for production environments. WebWatcher neither attacks the web applications with intrusive requests nor modifies the inputs of the applications. It does not generate dangerous traffic and populates the server unlike crawlers and web application scanners. WebWatcher analyzes normal user interaction flow throughout the security of the application. Low overhead, no training. WebWatcher provides valuable security insights with no special training requirements, dedicated systems, or any other high-end resources. NetSparker is an easy-to-use web application security scanner that uses the advanced proof-based vulnerability scanning technology and has built-in penetration testing and reporting tools. It finds and reports the vulnerabilities of web applications like SQL injection and the cross-site scripting on the various kinds of web applications without considering the technology and platform to be built with. NetSparker's unique scanning technology finds more vulnerabilities than any other scanner. NStalker Web Application Security Scanner is used for effective web security assessment checks. It enhances the overall security of web applications against a wide variety of vulnerabilities and sophisticated hacker attacks. Some of the web security assessment checks are as follows: code injection, cross-site scripting, parameter tampering, web server vulnerabilities. VampireScan is a web application security tool which allows the users to test their own cloud and web applications for basic attack and then for receiving the actionable results within their own web portal. Some of the features of VampireScan tools are: foremost, to protect the user's websites from the hackers. It scans and protects the infrastructure and web applications from cyber threats too. It gives the user direct actionable insights on high, medium, and low-risk vulnerabilities. A web application firewall is an application firewall for HTTP applications, which applies a set of rules to those HTTP conversations. It protects a specific web application or set of web applications, unlike proxies. That's why sometimes it is referred as reverse proxy. Some of the web application firewalls with their download links are given in the table. Let us discuss more about two of the most common web application firewall tools. Defender is a software-based web application firewall which complements with the network firewall, IPS, and other network-based internet security products. Defender is mainly used to inspect the HTTPS traffic for suspicious behavior and helps in detecting and blocking SQL injection attacks. Server Defender VP Web Application Firewall is designed to provide security against web attacks in an affordable and easy-to-use package for IIS admins. The key benefits of SDVP are: SDVP screens incoming data with a set of strict web application security controls, thereby preventing SQL injection attacks. Blocks access attacks often used in conjunction with phishing, social engineering, and other browser exploits. It prevents orphaned sessions. SDVP enforces your security policy in a stateful manner, making its web application security controls even more effective. Now you have learned about web application security tools. Let's check your understanding of this section. Give few features of the VampireScan tools. The features of VampireScan tools are: foremost, to protect the user's website from the hackers. It scans and protects the infrastructure and web applications from cyber threats. It gives the user direct actionable insights on high, medium, and low-risk vulnerabilities. What is web application penetration testing? Web application penetration testing, also known as pen testing, is the practice of testing a web application to find vulnerabilities that an attacker could exploit. It helps in identifying, analyzing, and reporting vulnerabilities, such as input validation, buffer overflow, SQL injection, code execution, bypassing, authentication, etc. In a given web application, penetration testing is performed by conducting a series of methodological and repeatable tests and then working through all the different application vulnerabilities one by one. Pen testing is done for 3 key reasons. For identifying ports. This is done by scanning the ports to identify the associated running services and analyzing them through automated or manual tests to find possible weakness in the web application. For verifying vulnerabilities, it is done by exploiting the vulnerabilities in order to test and fix the issue. For the remediation of the vulnerabilities, this is done to ensure that the application is completely secured by retesting the solution against vulnerability. Let us now learn more about pen testing by going through the complete process in detail. Information gathering is done as shown in this image. In this process, the system retrieves and analyzes the robot text file using the tools such as GNU wget. Using advanced site search operator, click cached to perform search engine reconnaissance. Identify application entry points using tools such as WebScarab, Burp Proxy, OWASP Tamper IE for Internet Explorer, or Tamper Data for Firefox. To identify the web application probe for URL, dictionary-style searching is used, in which intelligent guessing is done, and then a vulnerability scanning process is performed using the tools such as Nmap, which are Port Scanner and Nessus. Next, implements the techniques such as DNS zone transfers, DNS inverse queries, web-based DNS searchers, querying search engines. Analyzing the error codes by requesting invalid pages and then utilizing the alternate method requests, post, put, other, in order to collect confidential information from the server. Examine the source code from the accessible pages of the application front end. Testing the recognized file types, extensions, directories is performed. This is done by requesting common file extensions such as ASP, HTML, PHP, XZ, and then screening any unusual output or error codes. At last, performing the TCP, ICMP, and service fingerprints using the traditional fingerprinting tools such as Nmap and Quisco, or some more recent application fingerprinting tools like AMAP. The steps involved in configuration management testing is shown in the flowchart. Firstly, the ports associated to SSL TSL wrap services is identified using Nmap and Nessus. Next, scanning the network and analyzing the web server banner is done. Testing the application configuration management is done with the help of CGI scanners and the contents of the web server, application server, comments, configuration, and logs are reviewed. Vulnerability scanners, spidering and metering tools, search engine queries are used for manual inspection to test file extension handling is performed. Reviewing source code, enumerating application pages and functionality. Next, directory and file enumeration is performed. Reviewing server and application documentation is done to test for infrastructure and application admin interface. Review options HTTP methods using netcat or telnet. Authentication testing is performed by the following steps. Reset the password using guessing, social engineering, or cracking the secret question and gain access. Check if Remember My Password mechanism is implemented by checking the HTML code in the login page. Next, check if possible to reuse a session after logout. Also, check the possibility of user logging out automatically when the user has been idle for a certain amount of time and there is no sensitive data remains stored in the browser cache. Identify all the parameters that are sent in addition to the decoded CAPTCHA value from the client to the server and try to send an old decoded CAPTCHA value with an old CAPTCHA ID of an old session ID. Check if the user has a hardware device account other than the password. Check for the hardware device communication directly and independently with the authentication infrastructure using an additional communication channel. At last, perform the code review. After authentication testing, session management testing is performed by the following steps. Firstly, collect all the possible cookie samples that are sufficient to analyze the cookie generation algorithm, and then forge a valid cookie in order to perform the attack. Next, test the cookie attribute with the help of intercepting proxies such as WebScarab, Burp Proxy, QWASP Zap, or any traffic intercepting browser plugin such as Tampering and Tamper Data. Make a request to the site to be tested for session fixation and analyze the vulnerabilities using the WebScarab tool. Test for exposed session variables by inspecting the encryption and then reuse the session token, proxies, and caching. Get and post and transport vulnerabilities. Finally, examine the URL in the restricted areas to test for CSRF attack. Authorization testing. The steps involved in authorization testing are testing the path traversal by performing input vector enumeration and analyzing the input validation functions present in the web application, examining for the bypass authorization schema by testing the admin functionalities to gain the access of the resources which are assigned to a different role, and finally, testing for the role or privileged manipulation. Data validation testing. The steps involved in data validation testing are detecting and analyzing the input vectors for the possible vulnerabilities that exists in the web application and then analyzing the vulnerability report followed by an attempt to exploit it. OWASP, CAL 9000, WebScarab, XSS Proxy, Rat Proxy, and VARP Proxy are some of the tools used to perform the exploitation of the vulnerabilities. Next step is to analyze the HTML code. Test the stored XSS and verify the file if the upload allows setting arbitrary MIME types using tools such as OWASP, CAL 9000, Hack Vector, XSS Proxy, Backframe, WebScarab, VARP, and XSS Assistant, etc. Source code analysis is performed to identify the JavaScript coding errors. Analyze the SWF files using tools like SWF Intruder, Decompiler Flare, Compiler MTASC, Disassembler, Plasm, SWF-Mill, and debugger version of the Flash plugin player. Next is to perform standard SQL injection testing, unique query SQL injection testing, blind SQL injection testing, and stored procedure injection with the help of tools like OWASP, SQLIX, SQL Ninja, SQL Dumper, SQL Power Injector, etc. Check for the application error using a trial and error approach by inserting characters. After discovering the vulnerabilities of an ORM tool, testing the web application that uses ORM is performed using tools such as Hibernate ORM, InHibernate, and Ruby on Rails. Insert XML meta characters. Next is to check whether the web server actually supports SSI directives, or not using tools such as Web Proxy, Barb Suite, OWASP, ZAP, Web Scarab. XPath code is injected and then interfered with the query results. Identify the vulnerable parameters. Next is to discover the code injection vulnerability by injecting a malicious code and performing a source code analysis. Manual code analysis is performed, and malicious HTTP request is crafted to test for OS command injection. Manual and automated code analysis is performed using tools to detect the buffer overflow condition. Perform XSS and SQL injection attack. Finally, identify all the user-controlled inputs that influences one or more headers in the response and then check whether the attacker can successfully inject a CR/LF sequence in it or not. Denial of service testing. After data validation testing, denial of service testing is performed by the following steps. First step is to craft a query, does not return a result, and includes several wildcrafts. Also, include testing manually or employing a fuzzer to automate the process. Test for an account that does not log after a certain number of fail attempts and find places where the application discloses the difference between valid and invalid logins. Next is performing a manual source code analysis and submitting a range of inputs with varying length to the applications, followed by finding where the numbers submitted as a name-value pair might be used by the application code and then attempting to set the value to an extremely large range. Check if the server continues to respond after this or not. An extremely large value is entered in the input field, which is used by the applications as a loop counter. A script is used to automatically submit an extremely large value to the server in the request that is being logged in. Identifying and sending large number of requests that performs database operations and then observing any slowdown or generation of error messages. Finally, creating a script to automate the creation of many new sessions with the server and then run the request that it is suspected of caching the data within the session for each one. Web services testing. The steps involved in web services testing are: gather web services information using tools such as WSChess, SOAP, LITE, curl, and some online tools such as UDDI Browser, Xmethods, and WSIndex. WebScarab, WebDigger, and Foundstone are some of the other tools to automate the web services security testing. Some of the malformed SOAP messages are passed to XML parser, or a large string is attached to the message. WSDigger is used to perform automated XML structure testing. XML content level vulnerabilities are tested using web application vulnerability scanners like WebScarab. Next, malicious content on the HTTP GET string is passed to invoke the XML applications. An XML document like SOAP is crafted to send to a web service that contains malware as an attachment to check if XML document has SOAP attachment vulnerability. Finally, an attempt to resend a sniffed XML message is performed using Wireshark and WebScarab. AJAX testing. The steps involved in AJAX testing are: enumerate the AJAX call endpoints for the asynchronous calls using tools such as SPR-AJAX, observing HTML and JavaScript files to find URLs of additional application surface exposure, using proxies and sniffers, traffic generated by the user viewable pages and the background asynchronous traffic to the AJAX endpoints are observed to determine the format and destination of the requests. Web Application Pen Testing Framework comprises of techniques and tasks that are associated with securing the web applications from the vulnerabilities. Some of the frameworks are Kali Linux. It is an advanced penetration testing and security auditing Linux distribution containing more than 300 testing tools. Metasploit. It is a penetration testing toolkit, which is also an exploit development platform and an illustrative research tool that includes various working remote exploits for different platforms. It is very useful for verifying vulnerabilities and managing security assessments. Browser Exploitation Framework. It is an open-source penetration testing tool used to exploit and test the web application and browser-based vulnerabilities. PowerSploit. It is a collection of Microsoft PowerShell modules that is used to aid in reverse engineering, forensic analysis, and pen testing in all phases of the assessment. What is web application pen testing? Web application penetration testing, also known as pen testing, is the practice of testing a web application to find vulnerabilities that an attacker could exploit. This concludes the web applications and associated threats module. Let's take a few minutes to review the key points you have learned in this module. I will pause for a few seconds to allow you to read it. In the next module, we will learn about controlling user session with authenticated TCP connection. Thank you.